Hey everyone, welcome to our last lesson on 8.2 properties of chords in a circle. I just want to point out a few of the definitions for this and go over some of the chord properties. So in regards to this, I just want to go through and just talk about what a chord is. So a chord of a circle joins 2 points on the circle. So in this example right here that's in the middle of the magnifying glass, right here, you'll see that the chord goes along the bottom of the circle. Anything that goes through the center of the circle to the outside or intersects the circle in the middle will either be a radius or a diameter. All right, so the chord goes along the bottom of the circle, and it could be anywhere in this diagram. It just has it up here at the top, but the chord does go through there, and it just connects at 2 points down there. Okay. Moving on right here to chord properties, they are in any circle with the center 0 and a chord AB. So in this one right here, we have chord AB, all right? Then we can draw a radius line, and if OC bisects AB, that means bisects, of course, cut in half, that OC and AB are perpendicular. That's what that little line means there. That's like an upside down capital T. Means they are perpendicular. All right, so if OC and AB are perpendicular, then AC will equal AB. Okay, and what that means is that the 2 points right here in the middle, excuse me, from AC and BC or CB, however you're going to do it. All right. So the perpendicular bisector of AB goes through the center 0, or sorry, not 0, O. All right. So in example number 1 down here, I'm just going to bring my magnifying glass back up here so we can all see this. It says, example number 1, find the measures of angles in a triangle. So right here it says, find X degrees, Y degrees, and Z degrees. And you'll see here on the diagram that the one side where it's angle A is 30 degrees. If we look at angle X, we should know what that is because any line that intersects a line straight through the center or that creates a radius is going to be 90 degrees. So we're going to be able to figure that out right away. So angle X right here in the middle is going to be 90. Now, since these two triangles right here, when you cut the triangle in half, are going to have the same angles. Angle Z on the other side is also going to be 30 degrees. The one that you're going to have trickiness with is angle Y, or Y degrees. And then we would just use the angle sum property for that, where we have OC bisects chord AB. So OC is perpendicular to AB, therefore angle X is 90 degrees, which I just talked about. By the angle sum property, in triangle OAC, which is right there, OAC is the triangle, is to figure out the Y degrees is 180 minus 90 minus 30 will equal 60. We add all those up, and Z is obviously going to be 30 degrees, and that is how you would figure out the measures of angles in a triangle. And it looks confusing, but it's pretty straightforward if you pay a little bit of attention to this. Okay, so this is going to be part 1. I'm just going to do part 2 here in a second, and we'll be moving forward.